So we need to find the x and y intercepts of the function. Now when we're talking about f and y intercepts, it's important to know that to find the x-intercept, we are looking for the x value and y is equal to 0. And then to find the y-intercepts, I want to know what happens when x is 0 and I'm looking for the value of y. I always try to remember it as I am looking for x for the x-intercept, and I'm looking for y for the y-intercept, and the other value is 0. Now, what we're going to go ahead and start is we're going to start looking for the y-intercept. We do that by letting x equal to 0. So in function notation, what that means is I want to find out what happens with f of 0, which means I just go ahead and plug in 0 everywhere I have for x. So 2 times the absolute value of 0, the absolute value is just of 0 is 0 times 2, so that's 0. Lots of zeros in that one, so that's just going to be 0 minus 10 or equal to negative 10. Now if I write that as a point, my x value is 0 and my y value is negative 10. So that will be 1 point on the graph. Now for the next one, I want to find the x values. This one's a little bit, requires a little bit more steps, because what I'm saying here is I want to find f of x when it is equal to 0, meaning that this is my, when the y value is 0. So the way that I do this is I go back to my original function, which is my f of x function, and it is equal to 2 times the absolute value of 10, and I have to set that equal to 0, or find when that's equal to 0. So that becomes 2 times the absolute value of x minus 10, and I want to know where this is equal to 0. How I find that is by adding 10 to both sides, and now you are left with 2 times the absolute value of x is equal to 10. I divide both sides by 2, and now I'm left with the absolute value of x is equal to 5. However, that's not my final answer. Remember, whenever you have the absolute value of an equation, you have to split it into 2 parts. And you always do this after you solve for the entire absolute value. If in this case, it just gives us the fact that x is equal to both a positive 5 and x is equal to a negative 5. If I'm writing them as a pair of points, that would be 5, 0 and negative 5, 0. Next, we're going to graph this. So from the last slide, I've copied everything over. This is our function, the x-intercepts that we found and the y-intercepts I found. Now I'm going to take these 3 points and move them over to the graph. So we have negative 5, 0 right here, and 5, 0, and 0, negative 10, which is right here. Now, based upon what I know about graphs, this is going to make a V, and this looks like this. I'm going to go ahead and just draw this graph in. And it goes on in both directions. Now, what can I say about this graph? Well, I can also say that this point right here, my y-intercept, is going to be a minimum on the graph, and it would also be considered the vertex. So I can say that this point here is a minimum and a vertex of this absolute value function. In this absolute value functions, we can say opens going up, because up here going towards the top of my graph.